This is lesson 18, which is VHDL Example 6. And in this example, we'll design the 2-to-1 MUX using 3 different methods, including the VHDL if statement. Let's begin by recalling the equation for a 2-to-1 MUX from the previous example. Remember, this was the logic equation. And so we can just write a VHDL program. Here's the entity, inputs A, B, and the control signal S, and the output Y. And here's the logic equation, just not S and A or S and B. So that would do it. We could simulate it, and here's the simulation. If we use 3 clock signals for A, B, and S, make S the lowest frequency, then at twice the frequency A, and at twice the frequency again B, then this goes sort of 0, 1, 2, 3, 4, 5, 6, 7, and we cover all 8 cases of A, B, and S this way. And notice what Y is. Well, if S equals 0, first 4, then Y is the same as A, and when S equals 1, then Y is the same as B. So it is a 2-to-1 MUX. Okay, well, normally we don't write VHDL programs using the logic equations like we've been doing. Instead, what we do is we describe the behavior of our circuit. And you remember the behavior of a multiplexer is that if S equals 0, Y equals A, and if S equals 1, Y equals B. Well, we can just use the VHDL if statement to say that. We write if S equals 0, single bits have to have single quotes around them. These are literals. So if S equals 0, then, the word then is here, then Y gets assigned A with a semicolon, else Y gets assigned B, and then end if. Note that end if is 2 separate words followed by a semicolon. So that's the VHDL if statement. Let's see how we put it in a program. The if statement must be in what's called a process. A process can have a label here, this is optional, followed by the word process, and then begin end process, and in there is this so-called sequential statement, which in this case is an if statement. If S equals 0, then Y equals A, gets assigned A, else Y gets assigned B, end if. Now, following the word process is what's called the sensitivity list, in this case A, B, and S. Now, these are the 3 inputs to our circuit, A, B, and S, and you need to put in the sensitivity list all of your inputs, because in this combinational circuit, if any of these change, we want the output Y to change. So a sensitivity list contains everything that if any one of these signals or inputs change, then the process executes, as it were, and executes this if statement. So you must remember to put everything you want in the sensitivity list that if it changes, you want the process to execute. Also, notice that in this case we have a signal assignment, this less than or equal signal assignment operator, and these get evaluated at the end of the process. So although we say Y equals A here and Y equals B here, it really isn't until the end of the process that Y actually gets assigned A or B. Now in this case it doesn't make any difference because we're only going to pick one of these, but sometimes it will make a difference, and we'll see in later examples where this is important. The important thing to remember is that signal assignments within a process don't get evaluated until the end of the process. What it means is that the last one that gets assigned to anything is the one that actually takes effect. Okay, there's another way to solve this multiplexer problem. We can use what's called a conditional signal assignment statement. This is sort of a shorthand if statement, if you will, but does not have to be in a process. In fact, it isn't in a process. It's a assignment statement, like you'd write a logic equation, except we say y gets assigned a when s equals 0, else b. That means if s is not 0 or 1, then it gets assigned b. So this one statement is the same as the if statement we had in the process. So it's sort of a shorthand called the conditional assignment statement. Now, we could use any of those three programs for our 2-to-1 MUX, and if we wanted to implement it, we need to make a top-level design where we could use the switches. We'll use 2 of the switches for A and B. Switch 1 down to 0. We'll use the button for S. So S equals 0 means you're not pushing a button. When you push the button, that's S equals 1. And we'll display the output Y on the rightmost LED. Now notice that we have to put 0 down to 0 in both cases because both button and LD are arrays in the UCF file. So this will be 0 down to 0, button 0 down to 0. Then here we picked MUX 2.1b. That was where we used the if statement. So this is the component declaration as usual between architecture and begin. Our component declaration, A, B, S is in, Y is out. And then we use the port map to connect A to switch 0, B to switch 1, S to button 0, and Y to LD 0. So in this case, you can go ahead and download this to your Nexus 2 board, or whichever you have, and implement it. And when you push button 0, then whatever switch 1 is should show up on the LED, and if you're not pushing button 0, then whatever switch 0 is should show up in the LED.